Hi everybody, this is Math 026 Module 3 Part 1, and in this module we're going to look at complex numbers, completing the square, and the further solving of quadratic equations. We're going to start with complex numbers. In the start of the course, or at the start of the course, we talked about radicals. We talked about like if you had a square root or a fourth root or any even index, you couldn't have a negative number under the radical. But sometimes when you're dealing with math and you're dealing with calculations, you get that negative number underneath the radical. So mathematicians had to find a way to deal with this. I always like to say, infinity wasn't enough. So we had to come up with imaginary numbers, and that's how we deal with that negative under an even index radical. So that imaginary unit is defined as I, and I is equal to the square root of 1. So it allows us to deal with that negative radicand. And so, if we have I equals the square root of -1, then we know that I squared will be -1 because you're doing, I squared would be the same as the square root of -1 times the square root of -1, which we know will give us that -1, whatever's under that radical. I cubed is equal to -I, because again, I cubed would be the same as doing the square root of -1 times the square root of -1, and then another square root of -1 there. And we know that these two here will equal a -1. And then a -1 times, we can do the square root of -1, or we can substitute in, again, that I. -1 times I will give us our -I. And then I to the fourth power is always going to equal a 1. And that is because, think of it this way. It's like we have I squared times I squared, or we know I squared is equal to -1. -1 times -1 will always give us a positive 1. And really, if you know those 4 powers of I, you can solve any power of I, and we're going to do that in a second and look at it. I is always equal to I, or the square root of -1. I squared is equal to -1. I cubed is equal to -I, or the opposite of I, and I to the fourth power is equal to 1. Now, what we would do to deal with our negative radicands, if I have here, I have the square root of -45. Before we would say not a real solution. But now I can rewrite this. I know the square root of 49 is 7. So I can rewrite this as the square root of 49 times the square root of -1. We know that the square root of 49 is 7. We know the square root of -1 can be written as I. So my answer here, would be 7I. Same thing here with 50, -50. We can rewrite this as the square root of 25 times the square root of 5, not 5, but 2. Geez, what is that? All right, the square root of 2 times the square root of -1. 20, the square root of 25 is 5. The square root of -1 is I, and then we have our square root of 2. For C, we can break that down. 108 can be divided by 36 evenly. So we can rewrite it as the square root of 36 times the square root of -1 times the square root of 3. So it's going to give me 6I times the square root of 3 to simplify that. So again, when you have that negative under the radical now, pull it out as the square root of -1, which we will write as I, and that will help us simplify, and it's called using our complex numbers or the imaginary unit. All right, so now we are going to look at powers of I and figuring out what they can equal or what we can simplify them to. So just as a reminder, we talked about in the last slide, we know that I represents the square root of -1. Or we can also say, I to the first power, for simplifying in terms of I, it equals I. We know that I squared is equal to -1. I to the third power we talked about is -I. And then I to the fourth power equals a 1. So when we are going to simplify powers of I, really what we're trying to do here is we're trying to find out how many groups of 4 are in each power. So like I have I to the 15th power here. I can break that down and rewrite it as I to the 4th power times I to the 4th power times I to the 4th power. And those 3 4s, when we add them together, give me 12 times I to the 3rd power. Now, the reason I did this is because I know every time I have I to the 4th power, that equals a 1. So really, I'm doing 1 times 1 times 1 here, times now that I to the 3rd power, the leftovers that I can't turn into I to the 4th, is equal to a -I. So if I have I to the 15th power, it will simplify to -I. Now, you're probably like, well, I have I to the 562nd power next. I am definitely not sitting there and creating all those groups of 4. I agree. Here's the trick. Take your exponent, 562, and we're going to divide it by 4. So 4 into 562. I know 4 goes into 5 once. We'll subtract our 4. We have 1 left over. Bring down your 6. 4 goes into 16 4 times. Subtract our 16. We have a 0. Bring down your 2. And 4 does not go into 2, so I'm going to put a 0 as my placeholder there, and I'm going to work with remainders. So here's the deal. 4 goes into 562 140 whole times. This number is telling you how many 1s you have. So I would basically have 1 times 1 times 1 times 1 times 1 times 1, all the way up to 140 of those 1s. I don't really need to worry about that. What I need to know for my answer is my remainder. Like I said, for the first one, those turned into 1s. It didn't matter. It's the remainder that makes the answer. Since my remainder is 2, when I have I to the 2nd power, that equals a -1. Because I have a remainder of 2, I to the 562nd power, rewrite it here, will always equal or equals a -1. So you're really only looking at the remainder to figure out what your answer is. Now, if you have a remainder of 0, that means that 4 goes into it evenly perfectly, so your answer will always be 1. Now for C, we have a negative exponent. So the first thing we want to do is make that a positive exponent by taking the reciprocal. Okay. And now let's take and divide 4 into our 84. And 4 goes into 8 twice. And this is one where we're going to see that 0 remainder. 4 goes into 4 once. So 4 goes into 84 21 whole times with a remainder of 0. Remember, anything to the 0 power always equals 1. Or if you think about it, it goes in evenly. So this problem is going to equal 1 over 1, or we can simplify that into 1. So the main thing to remember here is divide by 4. Whatever your remainder is, that matches up with the exponents on your i's, and that will be your answer. And again, if your remainder is 0, so think I to the 0, that's going to equal your 1 as well. Hopefully that is helpful. All right, so now we are looking at just more information on complex numbers. An imaginary number is any number in the form of bi, where b is the real number. So again, imaginary, you have that coefficient in the front. Kind of think of it like a coefficient, the number in the front, and then your I would be second, just like you would write a variable on a term. And a complex number is a number in the form of a plus bi. So a and b are your real numbers, but whenever you're writing it in complex number form, the real number part goes first and the imaginary part goes second. So they want it kind of in a certain order. They want the real number part first and then the imaginary number second. You can do operations on complex numbers just like, really like working with terms. When you add and subtract, you can only add real numbers to real numbers, complex numbers to complex numbers, or imaginary numbers. So it's kind of like combining like terms. Multiplication, you can multiply, unlike terms or real to imaginary. But one thing we do have to remember is whenever we end up with an I squared, we want to convert it to -1. So we won't leave I squared terms. We'll convert those to -1 and simplify. And division, the operations are the same as rationalizing a denominator. Basically, you don't want an imaginary number in your denominator. So we'll multiply the numerator and the denominator by the conjugate of that denominator. Okay, so now we're going to perform the following operations and simplify and write our answer in standard form, which means standard form for this is going to be the a plus bi form. So the first one, we are adding two expressions, two binomials. Now, again, with addition and subtraction, you want to add like. So I'm going to add my real numbers together, my 3 and my 4, and that will give me 7. And then add my imaginary numbers. So -2i plus +5i will give me a +3i. And that's done. We can't do anything else with it. For b, we do have that minus sign outside of the expression, so we do have to distribute it to both. So we end up with 3 minus 7i minus 16 plus 13i. Just take the opposite of everything on the inside. Now combine like terms. So 3 minus 16 will give me a -13. And then -7i plus +13i will give me a +6i. Now for C, we are going to multiply here, and we can again multiply unlike terms. So 2i times 5, 2 times 5 is 10, and then we'll keep our I there, plus 2i times 2i will give me 4i squared. But here, when I talked about it before with the multiplication, anytime, and really with anything, here, if you end up with that I squared, that is a -1. So really right now we have this. We have 10i plus 4 times -1. And 4 times -1 will give me 10i minus 4. But notice right now we don't have it written in standard form, so we are going to swap it around. My final answer would be -4 plus 10i. Put it in that complex form. All right, D, again, is going to be much the same. We're going to FOIL here like we have been. So in past sections, 7 times 2 is 14. 7 times 4i will give me plus 28i. -3 times 2 will give me -6i. And then -3 times +4i will give me -12i squared. I'm going to start off, combine the middle terms. So I have 14 plus 28i minus 6i will give me 22i minus, and then I have 12, and that I squared, remember, make that a -1. So -12 times -1 will give me a +12. And then we can add the 14 and the 12 together. So that's going to give me 26 plus 22i. We'll write it in complex form. All right, for E, again, we are going to FOIL. Now this time we're going to deal with some radicals in there. with our imaginary numbers. So the square root of 8 times the square root of 2 will give me the square root of 16. We'll simplify that later. The square root of 8 times negative 7i will be negative 7i square root 8, because the 7i is not under a radical, so we're not going to multiply it under that radical. 2i times the square root of 2 will be plus 2i square root 2. And then our last two terms, 2i times negative 7i will give me negative 14i squared. So now we're going to simplify this. I'm going to start off with the easy part. The square root of 16, I know, is 4. Now, right now, the 7i square root 8 and the 2i square root 2, I cannot combine those two, but I can simplify that square root 8 times that negative 7i. So that will simplify down. That's 7i. I'm going to write it down here. 7i square root 8. Remember, I can rewrite that as 7i times the square root of 4 times the square root of 2, because I know that square root of 4 is a 2. So that's going to give me 14i square root 2. So I'm going to do minus 14i square root 2 plus 2i square root 2 minus 14, and that's an I squared, so times negative 1. All right, so now we have 4. I can combine these middle two now because they're like radicals. So negative 14i plus 2i will give me negative 12i square root 2. And then negative 14 times negative 1 will give me a positive 14. So now let's finish it by combining our like terms here. And when I do that, we will have 4 plus 14, so that will give me 18 minus 12i square root 2, and that'll be our final answer. All right, so for C, we have a squared expression. So remember, when it's squared, we're going to multiply the expression together twice. So 6 minus 3i times 6 minus 3i. I am going to FOIL, so 6 times 6 is 36. 6 times negative 3i will give me negative 18i. Negative 3i times 6 again will be negative 18i. And then negative 3i times negative 3i will be a positive 9i squared. All right, when we start simplifying, we're going to have 36 minus, excuse me, 36i, because I'm going to add negative 18 and negative 18i, plus 9 times negative 1, because that I squared equals a negative 1, and we do have to convert it. So now I have 36 minus 36i minus 9, because negative 1 times 9 is a negative 9. So then when I do my subtraction, 36 minus 9 will give me 27 minus 36i. And that will be our final answer there. All right, so here we are going to work with our division problems. And we want to make it so that we rationalize that denominator. We do not have I in our denominator. So here, when you have just a single term, the easiest thing to do is to multiply that by itself so that you get that I squared and can turn it into a negative 1. Just a reminder, whatever you do to the bottom, you also have to do to the top. So for 6 over I, I'm going to multiply it, the bottom, by I. And whatever I multiply the bottom by, I always have to multiply the top by. So we'll do I on the top as well. So that is going to give me 6I over I squared. But again, we remember that that I squared can be changed or rewritten as a negative 1. So now I have negative 1, 6I over negative 1. which we can rewrite as negative 6i. Now, we don't have a real number part to this problem, but if they want it in complex form, they want it in the a plus bi form. If they ask for it that way, a is 0, so we'll just put 0 minus 6i. Again, some places they'll take negative 6i. Other places, if they want it complex form, you'd have to add that 0 in the front. So that's a good thing to look at and know. All right, for h, again, I want to get rid of that I on the bottom. So we are going to multiply everything by 4i. And that will give me 16i squared over 28i. And that 16i squared, remember, it's 16 times negative 1 over 28i. So we're going to make that into negative 16 over 28i. And then again, I am going to simplify this. Now, because we have a negative on the 16, it really makes the whole fraction negative. I find it easier. Just typically we bring that negative, put it up with the 28i. It means that the whole fraction is negative. You can write it with the numerator, denominator, or right by the fraction bar. The one thing we do need to do with this is we do need to simplify it. I can divide out a 4 from both numbers. So it's going to end up being negative 7i over 4 for our final answer. And again, that is just written in imaginary form. If they want complex form, it would be 0 minus 7i over 4. All right, so now we are going to look at 2 where we have I in the bottom, but they are part of an expression. So just like when we were rationalizing our denominators, when they're part of an expression, we need to use the conjugate to clear that denominator of the I or the imaginary number. So we are going to multiply by 2i. Remember, your conjugate keeps the same terms, but instead of minus 1, it's going to be plus 1. And again, whatever I do to the bottom, I have to also do to the top. Now, I am going to leave the top as it is right now. We will probably need to distribute later, but for now, I'm going to just leave it as is and work on foiling that bottom. So 2i times 2i will give me 4i squared. 2i times 1 will give me plus 2i. Negative 1 times 2i will be negative 2i. And then negative 1 times positive 1 will give me a negative 1. Let's go ahead and we'll distribute on the top now. So we get 6i plus 3 on the top. On the bottom, 4i squared. Remember, it's 4 times negative 1. So it's going to be a negative 4. 2i minus 2i. Remember, those middle terms cancel out when you use a conjugate. So we have negative 4 minus 1, which is going to leave me with 6i plus 3 over a negative 5. Or, and I can't really do any simplifying here, but it's not written in complex form. What they want for it to be complex form is for you to break it up into the real number part and the imaginary part. So we want 2 fractions here. We want the real number part first. So I'm going to do negative 3/5 because the 5 is negative, so it makes this whole fraction negative. Minus 6i. Oops, that's an I, not a T. Minus 6i over 5. And again, this breaks it up. We put the real number part and the imaginary part. And because the 5 is negative, it makes both fractions, the 6i and the 3, negative when we split it up. So that's the final answer for that one. Let's take a look at J. Our conjugate here will be 1 minus I. And we'll multiply both top and the bottom by that. So let's go ahead. We'll FOIL the top and the bottom because we need to split it up when we get done. So we'll have 1 times 3 for the top is 3. 3 times negative I will be negative 3I. 5 times 1 is plus 5I. And then 5 times negative I will be negative 5I squared. On the bottom, 1 times 1 is 1. 1 times negative I will be negative I. Positive 1 times I will be positive I. And then 1, or I times negative I will give me negative I squared. So now we need to convert. On the top, we have negative 3I plus 5I will give me positive 2I. And negative 5 times I squared. Remember, that makes it a negative 5 times negative 1, which gives us a positive 5. So if I simplify that, I end up with 8 plus 2I on the top. Now on the bottom, my middle terms cancel out, which is what I want. And we have minus I squared, which is the same as saying minus a negative 1. Those two minuses there become a positive 1. So we have 1 plus 1 on the bottom, or we end up with a 2. Now I do need to break that up into two separate fractions, the real number part. So 8 over 2 plus 2I over 2. And when I do that, hopefully you see you can simplify that. 8 divided by 2 is actually equal to 4. And 2I divided by 2 will give me just, like the 2's equal to 1, so I'm left with just I. So this one actually simplifies to just 4 plus I, written in that complex form. That is it for part 1. I'll see you shortly for part 2.